All right, in this chapter, we're going to work on how to factor algebraic expressions. There's different factoring scenarios, different techniques depending on what we're looking at. So we're going to start by how to factor out a common factor. So factoring out a common factor is just using the distributive law in reverse. So, the distributive law is what tells us that if I multiply A by the sum B plus C, then I'm allowed to distribute this factor, right, to each of those terms, and we get A times B plus A times C. And factoring out a common factor is just that process in reverse. It's looking at an expression like we have here and noticing, oh, I've got this common factor of A, and then I'm going to take that out and then see what I have to multiply by each of by A to get each of these terms that we started with. We want to make sure that we factor out the greatest common factor, meaning take out everything that can come out, everything that they have in common. In example 3.1, let's see, part A here, we're looking at the expression 6x minus 2y. The common factor, the greatest common factor here is just the constant 2. So I'm going to take out a 2. Once I identify it, I start there, and then I open up a set of parentheses. Then we ask, what do I multiply by 2 to get 6x? And that is 3x. I bring down this minus. And what do I multiply by 2 to get 2y? And that would be just y. And so there we factored out the greatest common factor of 2. You can always check to see if you're right just by using the distributive property. If I were to distribute this factor of 2, we would recover the original expression. All right, in part B, we have 4ax squared plus 2ax. The greatest common factor, you might be looking at this and say, oh, both those coefficients are even, so I could take out a 2, and that's true. But look, you can also take out an a, and they also have an x in common. Now, you'll notice one of these terms has an x squared, and the other one just has an x to the first. So when you're taking out the greatest common factor, and you have different exponents, you always take out the least power. That's what they have in common. So the greatest common factor in part B is 2ax. And then we open up a set of parentheses. And what do we multiply by 2ax to get 4ax squared? Well, I need a factor of 2 to get me to 4. I've already got a factor of a, so I don't need any a's, but I do need a single x to get me to the x squared. Then I bring down the plus. And what do I multiply by 2ax to get 2ax? Well, that is just the same term, right? I multiply 2ax by 1 to get 2ax. And again, you can check this. If you distribute 2ax through the parentheses, you will recover the original expression. In part C, go ahead and give yourself a few seconds, see if you can't identify the greatest common factor. You might want to pause it if you want to have a go. Looking at this, I could tell, let's see, they both have a factor of 3, and that's the greatest common constant factor that they all share. At the a's, looking at the a's, a cubed is the highest power they all have in common. And looking at the x's, it's x squared is the highest power they all have in common. That's the least power among them. Opening up a set of parentheses, what we multiply by 3a cubed x squared to get 6a to the 5th x squared is 2a squared, bringing down the minus sign. We multiply 3a cubed x squared by 3x to get 9a cubed x cubed. And we multiply 3a cubed x squared by 1 to get 3a cubed x squared. All right, the next scenario is factoring a difference of squares. So we start just with a fact. X squared minus y squared will always factor as x plus y times x minus y. Now you can convince yourself that that's true simply by doing the multiplication. So if I multiply across, let's see, filling in the top row, we have x squared Then we have x times y. Along the bottom row, we have a negative x times y and a negative y squared. You can see that the plus xy and the minus xy cancel, and that just leaves us with x squared minus y squared. So convincing ourselves that this fact is true is not too hard. When we factor a difference of squares, the first step to factor a difference of squares is recognizing that you have a difference of squares. So in this first example, x squared is obviously a square, right? And then 16 is 4 squared. So I'm just going to write it explicitly as a difference of squares. And then using this fact, it'll factor as x plus 4, x minus 4. In the next example, 36x squared minus 49y to the 4th. Well, both of these are also perfect squares. 36x squared is the square of 6x, and 49y to the 4th is the square of 7y squared. Take a second and just convince yourself that's true, right? Using your rules of exponents, you could multiply out these squares and see that gives you the original expression. But now that I've written it as a difference of squares, I'm going to factor it. So we have a 6x plus 7y squared times 6x minus 7y squared. In the next example, 20x squared minus 45, I'm looking at this. It might not seem like a difference of squares, and this isn't actually a difference of squares as it's written, because 45 is not a perfect square, neither is 20, so 20x squared is not a perfect square. However, when we do factoring, the first thing I look for is a common factor. So we'll note first that there's a common factor of 5 that we can take out. So if I start by taking out a 5, then this will factor now as 5 times 4 x squared minus 9. And then this brings up another point, is that when we're factoring, we always want to factor completely, factor all the way. So after you've done one type of factoring, you don't want to just leave it. You always want to check and make sure that it's factored all the way. So the 4x squared minus 9, that can factor further, and I'm going to do that. 4x squared is the square of 2x, and 9 is 3 squared. So this will factor as 2x plus 3, 2x minus 3, and then of course I bring down that factor of 5, right? That comes with us. And that is as far as we can go. Next, x to the 4th minus y to the 4th. Both of these are squares. In fact, if you have x to an even power, or any variable to an even power, it'll always be a square because of how rules of exponents work. So x to the 4th is the square of x squared. Y to the 4th is the square of y squared. And so factoring this as a difference of squares looks like x squared plus y squared times x squared minus y squared. And again, we're going to stop and see if we can go any further. X squared plus y squared won't factor. In general, a sum of squares does not factor. But we do have another difference of squares on the end, right? So we can factor that again. So I'm bringing down the x squared plus y squared, and now I'm breaking this up. I'm factoring to get x plus y, x minus y, and that is as far as we go. Okay, so now our next scenario is factoring trinomials, and this is basically unfoiling, the FOIL in reverse. And FOIL, which is, usually when I factor, or when I multiply something out, I make the grid instead of using FOIL explicitly, but FOIL is the first, outer, inner, last, that sort of mnemonic that we use to multiply things out. So if we have a trinomial that'll factor like that, the first step is to say, okay, it's a trinomial. I know I'm going to have a couple sets of parentheses. I need the first two terms, when I multiply them together, to give me x squared. So that'll be x and x. I need the last two terms when I multiply them together to give me positive 2. So it's either plus 2 plus 1 or minus 2 minus 1. And in this case, it's plus 2 plus 1. And the thing you have to check, based on how we pick these terms, we're confident that the x squared, that the first term and the last term work out. It's getting this pesky middle term to work out. So this gives us plus 2x, this gives us plus x, and overall that gives us the plus 3x in the middle. Now, when you just have a plain old x squared or a prime times x squared, and if the end is a prime, that makes it easier to figure out because there's very few choices. If your number is prime, there's only basically one selection that you can make up to changing signs. If it's not prime, or if you have other options, it can make it a little bit more difficult. So here, again, we do still have primes, right? 5 is a prime, so I know 5 and 1, or negative 5, negative 1. 2 is a prime, so I know I'm going to have 2x and x. So it might seem really simple, and it is simple-ish, but we have to keep in mind that it will matter, when I'm thinking about this 5 and using 5 and 1, and I'm also pretty confident it's going to be a positive 5, positive 1, because in the end I need a positive, in the middle term I need a positive 11x. But if I did plus 5 plus 1 here, observe that this gives us plus 5x, and this gives us plus 2x, and that would only give us plus 7x. So that's not going to work. So I'm going to try it the other way around. Plus 1 plus 5, and now we have plus 11x plus plus 10x plus x gives us plus 11x, and that's what we wanted. Let's try another one. When I'm factoring, the first thing I look for, now we could dive in and just do, try to unfoil, set up our parentheses as is, and that's okay to do. But if you notice that there's a common factor, take that out first. It'll make the unfoiling a lot easier. So I notice all these coefficients, all the constant factors are even, so I'm going to take out a 2, and then that gives us x squared plus 3x plus 4, minus 4, rather. And now this is easier to unfoil, or factor than the original one, because we say that this is a monic trinomial, meaning the leading coefficient is 1. That usually makes it a bit easier. So we have an x and an x. Now to get a negative 4, I'm either going to have plus 2 minus 2, or a 4 and a 1, where 1 is positive and 1 is negative. I know it's not plus 2 minus 2, because if it were, this would be how a difference of squares factors, and this is clearly not a difference of squares, so I can eliminate that. So I know it's going to be a 4 and a 1. It's just which one gets the positive and which one gets a negative. I know they have to be different signs because it's a negative 4. And notice that it's a positive 3x in the middle, so I'm going to use a plus 4 minus 1, and then if you check, this is a plus 4x and a minus x, which gives us the minus 3x in the middle. And that is as far as this will go. Okay, so factoring by grouping is another way to kind of tease out a common factor. It just requires us to do, sometimes it'll require us to do a bit of organizing first. So we're going to start out with a simple expression where the grouping has already been done for us. And really this is just a simpler factoring out a greatest common factor, and actually maybe a little bit more complicated than the ones we did in the beginning, but we'll just note that if I look at, this, in this expression I'm subtracting two things, right? I'm taking this and I'm subtracting this, and between these two terms there's a common factor of x minus 1. So I'm going to take it out. Open up a set of parentheses. And what do I multiply by x minus 1 to get the first term? That's an h. What do I multiply by x minus 1 to get the second term? That's a 2. And then I just make sure I bring down that minus in between. And there it is, written as a factored expression. So in that one, they kind of did some of the work for us in the beginning. You know, we kind of had, we saw that we were subtracting a couple of products. In example 3.5, I look at this at first, it looks like it's just, you know, 4 terms. But I'm going to kind of group it like this, those 2 terms and those 2 terms. And if I look at the first couple of terms, I see that they have a common factor of 3. So I'm going to factor the 3 out of the first 2 terms. And then inside is x minus y. And then I'm bringing this plus over. In the second couple of terms, I could factor out an a, and then I get an x minus y. Now I could see that between these 2 products, I have a common factor of x minus y. I'll take that out. And then what goes inside the parentheses? Well, I need a 3, and I'm going to add, you know, bring over the plus, and then I need a factor of a to get me to the second term. So 3 plus a. And again, all of these you can check. All of these factoring problems you can check, because if you multiply this out, if you FOIL out these products, and you can make the grid, or you can use the mnemonic FOIL, you'll recover the original expression. So this next one, I'm going to do a similar type of grouping, I think, where I've got the first 2 terms and then these last 2 terms. Now, I'm going to look first at the first couple of terms, right? Ax squared minus x. I could take out a factor of x, and then inside I have a squared minus 1. With the next couple of terms, I'm going to be really careful about this subtraction. So I can either write it as plus a negative 3a squared plus 3, or, and what I'm actually going to do is write it as a minus parentheses 3a squared minus 3. And now I could see that there's still a common factor of 3. That doesn't change that. I'll erase this for now. But I could take out that 3, and then I have an a squared minus 1. And now we can see that there's a common factor of a squared minus 1 between these 2 terms. So I'll take that out. And then in the parentheses, we need an x, bring down the minus, and we need a factor of 3. Now we are almost done. Now this is, I have written it as a product of 2 things, but we always want to factor all the way. So this a squared minus 1, that can be factored further. That's a difference of squares. So that'll factor as a plus 1, a minus 1, and then we have this factor of x minus 3. And that is as far as this will go. Okay. Now these last 2, you know, it happened that I just sort of grouped the first 2 terms and the last 2 terms. That's not always the case. You know, sometimes you have to get a little creative with how you group them. So in this case, I'm actually going to group the first 3 terms and then leave the last one on its own. With the first 3 terms, we can unfoil that. So we'll need a y and a y. We need a positive 4, so it's either plus 4 plus 1, minus 4 minus 1, plus 2, or minus 2 minus 2. Right? That's the only ways I can get a product of positive 4. And if I want to get a middle term that's equal to a negative 4y, we're going to use a minus 2 minus 2. So I have 2 of the same factor, minus 2, y minus 2 times y minus 2. Well, that is, of course, y minus 2 squared. And now we might start to see what's happening. What I have is a difference of squares because 25x squared is the square of 5x, and now we can factor this as a difference of squares. We've got y minus 2 plus 5x and y minus 2 minus 5x. And that's as far as we go. You can again check this. If you know, FOIL won't work as a mnemonic here because that only works when you have just 2 terms in each factor, but you can set up the table right, to kind of distribute everything out, and you'll recover the original expression. All right, our last scenario is factoring a sum and difference of cubes. Now, we saw that a difference of squares factors, but a sum of squares generally does not factor. But with cubes, both the sum and the difference of cubes factors, and they factor according to these formulas here. You can convince yourself they're true by multiplying them out. But they all have, they adhere to the same pattern. So first of all, they all have a little factor and a big factor, right? The little factor you get is simply by removing the cubes. So x cubed plus y cubed, your first factor is x plus y. With x cubed minus y cubed, your first factor is x minus y. The big factor is always 3 terms, and you get each term by multiplying 2 things. So first you have x times x, then you have x times y, right, one of each, and then you have y times y. It always ends on a plus. It always ends on a plus, and this sign always differs from that sign. So that's just how you can kind of remember how this goes, and I can't emphasize enough, doing practice is good. It will kind of help solidify this pattern. Once you do several of them, you kind of get used to how it works. So we'll begin. Here I've got x cubed plus 8, and the first step in factoring a sum or difference of cubes is to recognize that you're looking at a sum or difference of cubes. 8 is a perfect cube. It's the cube of 2. So this is a sum of cubes. I'm going to have a little factor and a big factor. My little factor is just x plus 2. My big factor is x times x, which is x squared. And then we have 2 times x, and then we have 2 times 2, which is 4. It always ends on a plus, so I got a plus 4, and then this sign always differs from this sign, so that's a minus 2x. And that is as far as this can go. Generally, the big factor, you might look at this last factor, the x squared minus 2x plus 4, and think, well, can we unfoil that? And you could try on occasion. It might work out that you can, but in general, it is the case that that quadratic, that trinomial that you're left with at the end, doesn't factor. X cubed minus 1. Well, 1 is, of course, 1 cubed. Right, so the first thing I'm going to do is just write this as x cubed minus 1 cubed. It's a difference of cubes, so I've got a little factor and a big factor. My little factor is x minus 1, just remove the cubes. My big factor, x times x times 1, 1 times 1, always ends on a plus. This sign always differs from this sign, so that's going to be a plus. Okay, next, 8 minus 27x cubed. 8 is 2 cubed. 27 is a perfect cube, that's 3 cubed, so that means that 27x cubed is the cube of 3x. So this will factor as 2 minus 3x initially. Then in the middle, I'm going to have 2 times 2, or 4. Then this will be a plus because it differs from that sign. 2 times 3x is 6x, and then plus 3x times 3x is 9x squared. Okay. Now at first here it looks I definitely see some cubes. I got a cubed and b cubed, but 12 is not a perfect cube, nor is 96. However, there's a common factor we could take out first. 12 actually goes into 96, and they both have a factor of a cubed. So I'm going to take out a 12a cubed, and then inside we have 1 plus, and let's see, if you take 96 and divide it by 12, you get 8, so this is 8b cubed, and 8 is a perfect cube, so that means this is 12a cubed times 1 plus 2b all cubed. So 12a cubed, bringing that factor over, and I've got a little factor, 1 plus 2b, and then with my big factor, 1 times 1 minus 1 times 2b, always ends in a plus. 2b times 2b is 4b squared.